So, last class I have calculated that the total forces, horizontal and vertical forces of a gravity retaining wall, and then I determine the moment also. Now, this class I will apply those values. So, now for that purpose, so let us go for that problem. So, that this is the problem that was chosen, and these are the values. The of that total vertical force was 177.61, total horizontal force is 46.8, total resisting moment is 288.8, total overturning moment is 78.2. Okay, so, now first check I will do for the sliding. Okay. So, factor of safety for sliding, and as I mentioned, that is if your base soil, it is a C phi soil. Okay. So, the sliding will be equal to that C A into the B, okay, plus summation of all vertical forces into tan delta divided by summation of all horizontal forces. So, C A value is 25 is the C value into alpha, alpha is the 0.9 and B is 3, then plus summation of all vertical forces is 177.61 into tan delta is 15 degree. Okay. So, remember that when you calculate the earth pressure, that delta will be the delta of the backfill, and when you use this sliding check, then that delta will be delta of the base soil. Okay. Here we are using two different properties. Backfill soil is one property and the base soil is the another properties. Okay, because base soil is basically the existing soil and backfill soil is the filling soil. So, we are taking two different properties. If the properties are same both the soils, then you can use the same delta for the stability calculation or sliding sliding check and the Ka calculation. But here we are using two different deltas. So, remember that when you are calculating Ka, that delta will be the backfill delta, and when you are calculating the sliding stability, then that delta will be the base soil delta. Okay. So, base soil delta is the 15 degree. So, we are taking 15 degree, and then the divided by all the summation of horizontal forces is 46.8. So, this is equal to, this value is equal to, we are getting that 2.5 and which is greater than 1.5. So, it is okay. Okay. So, next one I will do the factor of safety for overturning. Okay. So, factor of safety for overturning is summation of all resisting forces divided by summation of overturning resisting moment divided by summation of overturning moment. Okay. So, this summation of resisting moment is 288.8 and summation of overturning moment is 78.2. So, summation of resisting moment is 288.8 and the resisting overturning moment is 78.2, resisting moment by overturning moment. So, this is coming out to be 3.7, which is greater than 1.25 to 2, so safe. Okay. Then we will for the no tension check. Okay. So, the x bar that I discuss, that this I have already discussed how to calculate this x bar. So, this x bar is summation m r minus m 0 divided by all vertical forces. So, this is 288.8 minus 78.2 and vertical force is 177.61, that is equal to 1.2 meter. So, the eccentricity E is B by 2 minus x bar. Now, B is 3 meter divided by 2 minus 1.5. So, this is 0.3 meter. Now, that is less than B by 6, which is 0.5 meter. Okay? So, it is okay. Now, for the bearing capacity calculation. So, bearing capacity calculation, what I will do? I will use because we have various bearing capacity expressions available, Stazaki, Meyerhof, okay. So, Skempton, Hansen, basic, but here it is an inclined load condition. You can see, because reaction, there is a horizontal force as well as the vertical force. So, it is an inclined loading condition. Okay. So, that is why we will use here the Meyerhof bearing capacity expression. So, I am using here Meyerhof bearing capacity expression to calculate the bearing capacity, and you know that Q net ultimate is equal to Q ultimate minus gamma dF, and that is equal to C NC SC DC IC plus gamma dF NQ SQ DQ IQ plus half gamma B n gamma S gamma D gamma I gamma minus gamma dF. Okay. Now, from the Meyerhof table we have a phi value of the base soil. Okay. Phi value is 20 degree. So, we have a phi value of 20 degree. Okay. So, corresponding bearing capacity factor we will get from the table. So, phi value is 20 degree. So, NC we are getting as 14.8, NQ we are getting as 6.4 and N gamma is equal to 2.9 from the table. From the table that was provided during the shallow foundation bearing capacity calculation. Okay. And it is a plane strain condition. So, it is a strip footing, retaining wall is length is very large compared to the width. So, it is a strip footing. So, for the strip footing I can write that SC, SQ and S gamma all are equal to 1, because it is strip footing. So, your this B by 0, B by L is equal to 0. I can write the expression also, that for example, SC expression from as per Meyerhof 1 plus 0.2 Kp B by L. Okay. And another thing is that here as there is a eccentricity, so your B will change. Okay. Now, the new B will be B dash, and that B dash is B minus twice E. Okay. So, B is 3 meter minus 2 into 0.3 meter, your U is 0.3 meter. So, your B value B dash is 2.4. So, everywhere we have to use the B dash, here also we have to use the B dash, because this is the eccentric loading. So, B dash fine. So, now as for strip footing your L is very large compared to the B dash. So, I can write that B by L is equal to 0. So, if I put B by is equal to 0, then S c is equal to 1. Similarly, S q and S gamma will also be 1. Okay. Now, our C value is given 25 kPa and gamma is, so C value is 25 kilonewton meter square, gamma is 18 kilonewton per meter cube. Okay. So, I am writing that C is 25 kilonewton per meter square and gamma is 18 kilonewton per meter cube. Now, we have to and dF, depth of foundation is 1 meter, because here this is the depth of foundation D below the existing soil, and that is 1 meter. So, this is dF is or D or dF is equal to 1 meter. So, now I have to calculate dC, depth factors and the inclination factors. So, I will calculate now dC. So, as per Mayer of dC is 1 plus 0.2 tan 45 degree plus phi by 2 into dF by B dash. Okay. And again your phi value is 20 degree. Okay. So, I can put these things 1 plus 0.2 tan 45 degree plus 20 divided by 2, dF is 1, B dash is 2.4. So, it is coming out to be 1.12. Similarly, dQ is equal to d gamma is equal to 1 plus 0.1 tan 45 degree plus phi by 2 into dF by B dash. So, if I put this value, it will be coming out 1.06. Okay. Now, IC equal to IQ is equal to 1 minus xi divided by 90 degree square, or in the actual table it is given 1 minus alpha 90 degree square. What is alpha? Suppose this is your footing, this is the vertical line. So, this is the direction of the force and this is alpha, okay, or xi. So, how I can calculate alpha here? Because here I have the alpha, this is the P, okay, and I have the horizontal forces as well as the vertical forces. Okay. So, this is summation of all vertical forces, this is summation of all horizontal forces. Okay. The reaction is you are acting in this way, na? Because this is the base of the retaining wall, your reaction is acting in this way. Okay. So, I have discussed that, and here this will be the R V dash, that is the summation of all vertical forces. These will be the R H dash, that is the summation of all horizontal forces. Okay. So, this is the reaction R. So, the alpha value will be equal to here is tan inverse summation of all horizontal forces divided by summation of all vertical forces. Okay. So, because we are calculating this angle, actually we are calculating this angle. So, this angle, this is all summation of all horizontal forces, this is summation of, this is the alpha angle. Okay. So, this is the summation of all horizontal forces which is acting this direction, and this is summation of all vertical forces which is acting this direction. So, this is alpha, this is the summation of all horizontal forces, this side is summation of all vertical forces. I can write. So, that means here this is the reaction is acting R, this is the alpha. So, this one is the summation of all vertical forces, this is summation of all horizontal forces. So, alpha will be tan inverse summation of all horizontal forces divided by summation of all vertical forces. So, I can write tan inverse summation of all horizontal forces is 46.8 and vertical forces is 177.61. So, this is 46.8 divided by 177.61. So, this angle is 14.8 degree. So, this value is 14.8 degree. So, this is 1 minus 14.8 divided by 90 whole square. So, this is equal to 0.7. Similarly, the I gamma is 1 minus alpha divided by phi square, okay, or 1 minus xi by phi square, and here alpha equal to xi equal to 14.8 degree. So, if I put that value 1 minus 14.8 degree and phi is 20 degree. So, that is equal to 0.07. Okay. So, now I am putting all this value here Q net ultimate, and I am getting that C is 25, NC is 14.8, SC is 1, DC is 1.12, then IC is 0.7 plus gamma is 18, IQ 1, NQ is gamma is 18, DF is 1, NQ is 6.4 because NQ is 6.4, and then SQ is 1, DQ is 1.06 and IQ is 0.7. Okay. Then plus this is half, unit weight is 18, then B dash is 2.4, then N gamma is 2.9, then S gamma is 1, D gamma is 1.06 and I gamma is 0.07 minus DF is 1 and unit weight is 18. So, that is equal to 362.2 kilonewton per meter square. Okay. And so, this is the stress. Now, the total force Q n ultimate will be equal to Q net ultimate into B dash. So, this is 362.2 into 2.4, that will be equal to 869.3 kilonewton per meter. Okay. So, the factor of safety will be equal to the Q net ultimate divided by total vertical force. Okay. So, that is equal to 869.2 divided by total vertical force is 177.61. So, total vertical force 177.61. So, that is equal to 4.9. So, this is greater than 2.523. So, it is safe. So, this is the total design of this gravity retaining wall. So, before I finish this design, one thing I want to mention that sometime instead of using this stability, instead of using B, you can use B dash also. okay, because this is the effective area, you should use the B dash. So, instead of using B, you can use C A B dash summation of V tan delta divided by summation of H. Now, if we use these things, if you use B dash, if we use B dash is equal to 2.4 meter, then the factor of safety will be equal to, for the sliding will be equal to 2.2 instead of 2.5. So, I will recommend you use B dash instead of B, and then this is again it is greater than 1.5. So, it is okay. Okay. So, this is the total design that I have done. So, first the sliding check, then for the overturning, no tension condition and the bearing capacity check that I have done for this particular problem. So, in the next problem that I will solve, it is a your cantilever retaining wall. So, I have solved the problem for gravity retaining wall. So, next problem that I will solve is a cantilever retaining wall, and I am choosing one particular problem for this case. Okay. So, the example that I am taking is a cantilever retaining wall . Okay. So, this again the height of this wall from here to here, this height is given 4.8 meter, okay, and this one we have chosen for the first trial 0.6 meter, and the depth of this foundation is again I have chosen 1 meter. Okay. Now, the width of this top portion is 3 meter I am taking, and this is an inclined backfill. Okay. So, the inclined angle is I is equal to 15 degree, and this one is taken 0.6 meter or chosen 0.6 meter. Now, this part is 0.2 meter, this one is 0.3 meter, and this one is chosen 3 meter. So, this is the total dimension, that was these total dimensions are chosen for the first trial. So, the total this dimension is 4.1 meter. Okay. So, this is 3 meter plus 0.6 plus 0.2 plus 0.3, that is 4.1 meter. Okay. And this is the toe of the wall. So, first we will check whether we can use Rankine's equation or not. Okay. So, as I mentioned, this is the line and this is the alpha and this is the xi, and xi expression is given that 45 degree plus I by 2 minus phi by 2 minus sin inverse sin I divided by sin phi. Okay. So, here the backfill soil phi is given 32 degree or phi dash in terms of effective, this is delta is taken 23 degree is given, unit weight is 19 kilonewton per meter cube, and Q net ultimate is given 400 kilonewton per meter square. So, what is the difference? In the previous problem, the soil properties properties were given. So, we determine the load carrying capacity of the foundation, but here the load carrying capacity Q net ultimate is given. Okay. So, we have to determine the factor of safety. So, the unit weight of concrete is equal to 24 kilonewton per meter cube, and you have to design this retaining wall. So, first check that. So, this is 45 degree plus 15 degree divided by 2 minus phi is 32 degree divided by 2 minus sin inverse sin 15 degree divided by sin 32 degree. Okay. So, this is equal to, this value is 7.26 degrees. So, it is 7.26 degrees. So, definitely you can check that this is 4.8 meter, this one is 3 meter. So, it is 7.626 degree means it will pass through the backfill, it will not touch the wall. So, we can use the Rankine theory. Thus, theory can be applied. So, we will apply the Rankine theory here. Okay. So, this problem we can apply the Rankine's theory, and so for the Rankine's theory K A expression for the inclined backfill is cos I into cos I root over cos square I minus cos square phi divided by cos I plus root over cos square I minus cos square phi. So, I value is 15 degree and phi value is 32 degree. So, if I put this value, this K will come out to be 0.34. So, my P A is equal to half into gamma into H square into K A. Now, here as I mentioned, we are applying the Rankine's theory. So, the force we will apply here, and it is parallel to I, okay, parallel to the backfill surface. So, it will be I. So, this is P A, and now we have to consider the total height of this surface or this face. So, total height in this case H will be, this is 0.6, 0.6, then plus 4.8, 4.8 plus this portion. This portion is how much? This is 3 meter, this is 15 degree. So, this one will be 0.8. Okay. So, you can calculate this portion is 0.8 meter. How we are getting that? Because this is 15 degree and this one is 3 meter. So, you can calculate this is 0.8 meter. So, total H is coming out to be 6.2 meter. Okay. So, this is 6.2 meter. So, K A. So, that is why half into gamma is given 19, H is 6.2 meter whole square and K A is 0.34. Okay. So, that is equal to 124.2 kilonewton per meter. So, now it has two component again, P A V, that is equal to P A cos I. Okay. So, sorry, P A H First we are calculating PAH, which is the horizontal one. PAH is cos I. So, this is 124.2 into cos 15 degree. So, that is equal to 120 kilonewton per meter. Similarly, PAV, this is PA sin I. So, that is equal to 32.15 kilonewton per meter. So, that means now it has two components, one is acting this direction, another is acting this direction. Okay. So, now if I taking this is the PA, now this is the PAV and this is the PAH. Okay. Now, this angle is I, which is 15 degree. Okay. So, that is the all the forces I have calculated. So, next task is that we have to calculate the forces, then the moment, and again we will do the check. Okay. So, that checking we will do in the next class. So, before I finish this class, I want to mention that in the previous problem that we have used this B dash part. Okay. So, this B dash part. So, in this problem we can solve in two ways, in two methods. Okay. So, first method that I have discussed, this is the first method. In the second method, so this is the method 1 that I have discussed. Another method that you calculate Q max. Okay. You calculate Q max by this summation of V divided by B 1 plus 6 E divided by B. Okay. Then compare this Q max with the ultimate net ultimate bearing capacity. But remember that during the calculation of net ultimate bearing capacity, if you are using these expression, do not use B dash, you have to consider only B. Okay. So, either if you use B dash, then you have to follow this technique. If you use this method, then do not use B dash, you have to use the B, then you use the B in bearing capacity equation, then you get the Q net ultimate. Okay. Then the factor of safety will be Q net ultimate divided by Q max. That should be greater than 2.5 to 3. So, this is the information I should share with you, that if you are using B dash, then use these techniques, that you calculate the force, then you compare with the force. But if you are using Q max, then do not use B dash, use B, and then calculate the load carrying capacity Q net ultimate, then compare with that Q net ultimate with the Q max, and that should be greater than 2.5 to 3. So, any one of them you can use. So, I would prefer to use the method 1 rather than, or you can use the method 2 also. Okay. I have used the method 1 here. So, in the next class what I will do, I will do the checking for this cantilever retaining wall also, that as I have done for the gravity retaining wall. The similar way I will do these checkings, that those 4 checkings, that is sliding, overturning, no tension and the bearing. Okay. So, this with this I am finishing today's class, and then the next class I will first do this checking, then I will go for the next section of this course, that is the design of sheet pile. another kind of retaining structure, and then I will also discuss what are the difference between the sheet pile and this retaining wall. Basically, these are the rigid retaining wall, rigid type of retaining wall, but the sheet pile is the flexible kind of retaining wall, but where we will use those retaining walls. So, those things I will discuss in the next class. Thank you.